Hey, hello everyone. Welcome back to my YouTube channel. My name is Sunny Savita, and in this video, we're gonna build one real-time solution with MongoDB and Pinecone. So, guys, I was creating the video on top of the RAG retrieval augment generation. I created many more video on top of it, and I try to explain you each and everything with respect to the RAG, whether it's a multi-modal RAG or the other part of the RAG. Okay, I try to explain each and everything from scratch. Now guys, I told you that I will be coming up with a different solution, not like the random one. So I'll be creating each and every video in the sequence. So in order to that, I came up with this Mongo DB with Pinecone. So in the previous video we have seen that how we can utilize NoSQL database, that is MongoDB, as a vector search. So in that video I shown you, if we have a NoSQL database that like MongoDB or other one, the like data stack, sorry, this Cassandra or Redis, okay, how we can utilize it as a vector search. I just created one video on top of the MongoDB. Rest of the video will be uploaded. Now, guys, I have seen and I have seen at the many places that people are using the combined solution in the real time. They are using the combined solution. So they are taking one NoSQL database and the other one is the vector database. Why, guys? Why they are doing like this? Because see, in the real time, actually, we have a lots of data, right? Whether we are talking about the tabular data, structured data, unstructured data, or semi-structured data. So whenever we get the real time data now, in that actually we have lots of column, lots of other different type of metadata and all. So just by using the vector database, we cannot build the solution. It's very tough. So along with that, actually, we need to use some other database which can hold the metadata. Okay, so we can hold the embedding by using the vector database, and we can hold the metadata by using the other NoSQL based database, SQL or NoSQL, but generally we use the NoSQL database only. So here, guys, that's why I came with this particular solution where we are going to be create one RAG pipeline, end-to-end RAG pipeline, by using this MongoDB and this Pinecone. And apart from this one, I will clarify each and everything with respect to the RAG. Okay, with respect to the other databases also. Now, apart from that, what is the NoSQL databases? So each and everything, each and every landscape, I will be clarifying over here itself. Now, let's begin from starting. So first of all, guys, let me show you my YouTube channel. If you haven't visited that, so please go and check, because there I uploaded many more video with respect to the RAG, and I try to complete one playlist as well. Okay, so here inside those inside that playlist you will find out around 30 videos. Here you can check. Now I have one. So one with respect to the multimodal RAG, the second one with respect to the RAG, and the third one for the generative AI. In that actually you'll find out every video like generative AI introduction, llama index, and all everything. So definitely you can check out if you are willing to learn this generative AI, and it will help you a lot. Now guys, here first of all let me clarify all the basics and the theoretical stuff, so you won't feel lag whenever you are learning these type of thing. Okay, no SQL or vector databases. I would like to clarify few theoretical stuff, and then I will come to the practical, then how you can solve this type of problem. So here guys, inside the theory, I kept a couple of theoretical point with all of you, so that most of the thing will be clarified over here itself. Now guys, here see, I written 7 points. So one by one, step by step, we are going to be discuss this particular point. So the first point, what is a NoSQL database? If you don't know, guys, this thing is going to be clear. Let me hide my camera so that you will get the access of the entire blackboard. Now here, guys, the second one, type of the NoSQL databases. So the third one, what is a vector database? The fourth one, benefit of using vector database. The fifth one, NoSQL database as a vector database. Then sixth, what is a combined solution and its benefit, and how to choose vector database. So these 7 points I have written so that each and every theoretical stuff will be clear to all of you. Okay. Now the first one, the first point is what? What is a NoSQL database? So NoSQL data means what? So here guys, we can store and retrieve the data, okay, without the SQL language. Means here I'm saying I no need to require SQL, and I no need to store the data in the tabular format. Without that, actually, I can store the data and I can retrieve. And here, don't use this SQL language, okay, for any kind of storage or for any kind of retrieval. And that's the meaning of the NoSQL. It is called not only SQL. and here I mention it, not only SQL. So now whenever we are talking about this NoSQL database, guys, so it is having some sort of an advantage, right, on top of the SQL database. So those advantage also we'll try to discuss over here. Now, first of all, guys, let me show you the type of the NoSQL databases, which is very, very important. Now, again, I'm saying this video is not dedicated to the databases. This video is dedicated to the combined solution. But here I want to like clarify some basics. That's why I came with this theoretical stuff. Okay. Now, the second point is what? The second point is type of NoSQL databases. Inside that, you will find out different type like document based, key value store, wide column store, or columnar family store, or graph databases. Now, in the document, basically, how we are going to be store the data? We are going to be store the data in the form of JSON, right? I think you know about the JSON. So, like this, we can create the JSON object, and in that, we are going to keep the data inside the key and value, right? So, this is what this is called my document, and in this particular format, we are going to be store the data. Now, MongoDB and CouchDB is one of the example of this document database. Now, apart from that, we have this key value store. So in the key value store, you can see Redis and DynamoDB comes. Now, whenever we are talking about the key and value, so this is different from this document database. In document database, we keep the data in the form of JSON. But here in the key and value pair, in the key and value storage, we don't create the JSON object. We simply create the key and value pair over there. Okay. So every single item in the database is stored in the attribute name, that is key, and together it's a value. So whenever I will be doing a practical with respect to the NoSQL databases, then definitely I will be showing you that. Now here in this particular video, we are going to use the MongoDB. So definitely you will get to know about it, how we can create the document from the data. This is how we can create the key and value from the data. Okay. Now here the second one is called, third one is called wide column storage, or it is called columnar family. So here also we create the column, here also we create the table, and the data which we access, not the row wise, actually we access the data based on the columns. Okay, so here Cassandra or Google Big Table, these are the pretty common example, or pretty like important as well. Okay, now the next one is called the graph database. So here actually we are going to be design a data, or we are going to be store the data in this graph format. Okay, where actually you will find out the node and edges, right? So graph, how the graph looks like, tell me. So in the graph actually you will find out. So let's say this is what, this is my A point. Now here is what, here's my B point. Now this is what, this is my C point, right? So in between actually I have to make a graph. So let's say this is what, this is my graph. Okay, so here this is called the node. So this is what, this is the node, and here this is what, this is the edges. So likewise actually we are going to be store the data, and here we are going to showcase the relationship in the form of this node and edges, right? I hope this thing is clear. Now whenever we're talking about this graph based database, so there actually you'll find out this Neo4j and this Amazon Neptune. So this two database, actually it's called the NoSQL graph based database. So I hope this thing is clear to all of you. Now see guys, whenever we are talking about the NoSQL database, we can divide into the multiple category, and some of the database nowadays we can use as a vector search also. We have a dedicated vector database, but in these database we can use some database as a vector search. So those database, the name of those database, definitely I will be showing you in this session itself. Now apart from this one, I have written some sort of an advantage of this NoSQL databases. So at least someone is asking you, to definitely you can explain. So let me tell you that. So first is scalability. It's a very scalable horizontal vertical. Generally we use the vertical, generally we scale on a vertical, generally we scale it on a vertical, horizontal level, not a vertical. No SQL data, SQL based database actually we scale on a vertical level, but here this no SQL horizontally. What is a vertical scale? What is a horizontal scale? I will be talking about in the upcoming session when I will be discussing about the databases. Okay, dedicated databases. Now here is distributed architecture. So yes, it's a horizontal. We can do the horizontal spread. So definitely it's it provides the distributed architecture. Now here manage large volume of the data. Definitely it can manage the huge amount of the data, and there's no SQL databases. It is being used in the real time also. Now flexible schema, yes, it is having a flexible schema compared to the SQL, means on the runtime itself we can change the schema. Okay, now high performance, high availability, development speed. So these all are the advantage of the NoSQL database, and it is true guys. So whenever we are going to implement it in a real time in the project, definitely you can feel these a particular thing, right? Scalability, distributed architecture, manage a larger volume of the data, flexibility and all. Now, I hope this introduction is enough to all of you to understand about the NoSQL database. So here I just written the notes for all of you before starting with the session. So at least we can save our time and you can understand the thing in a crisp manner. Now coming to the next part here, that is what, that's a vector database. So let's try to understand the same thing with respect to the vector database also, and then I'll be giving you that particular solution where we can combine both. Okay. Now, guys, whenever we are talking about data, now let me clarify one thing over here. Whenever we are talking about the data, so this data actually we can divide into two parts generally. The first is called the structured data, okay, structured data, and the second is called the unstructured data, right? Unstructured data. Now, in the structured data, actually, generally you will find out this tabular data, where what we have, tell me, where we have these columns, right, or attribute or features, anything you can say. So this column can be a categorical column or can be a numerical column. Now, if we are talking about this unstructured data, so there actually you'll find out the text, right, images, video. Actually, it's a form of the text, images, and audio itself. So audio is there, so text, images, audio, this type of data is called the unstructured data. Now whenever we are talking about the NoSQL data, so we can save both type of data. Yes guys, so whether it's a tabular data, so we can store it, let's say we are using MongoDB, so we can store it in the form of document. If we are talking about the Cassandra, so we can store it in the column families, right? If we are talking about the graph Neo4j, so we can store this particular data in the graph format. Now, similarly, we can store the text, images, audio, anything we can store inside the NoSQL database. And the real time, you will find out one of them, right? Either tabular, text, images, or audio, right? In the generative AI applications also. Now, coming to the vector database. So, this vector database, guys, let me switch off my camera so that you will get the access of the entire screen. So, here, if we are talking about the vector database, guys, so a vector database is a specialized type of database designed to efficiently handle vector data. Now, what is a vector here? So vector is nothing. Vector means it is representing to the set of value, right? So the set of value actually, let's say set of value means 0 0.1, 0 0.5, 0 0.8. This is what? This is the set of value. Now this value, this arrays actually we can store inside the vector database. Now here, like we use it inside the generative AI related application. I think you all know about it. In the many classes, in the many previous videos, I already explained you that part. So here, generally we use this vector database, guys. Here I mentioned one word that is called the similarity search, right? For the similarity search. So whenever we are querying something, okay, so this query actually, it will be in the form of the embedding, and we are going to check the similarity between this array and this array. And what we are going to find out, we are going to find out the similarity search. So any type of data, whether it's a text data, image data, audio data, any type of complex data, we can convert into the embedding and we can store inside the vector database. Now, whenever we are talking about the vector database, guys, so we have some characteristic related to this vector database. So here's some of the characteristic: storage of high dimensional vector. We can store the high dimensional vector. Efficient similarity search. It provides the efficient similarity search. Index mechanism. It provides the indexing. Okay. Advanced indexing also, like KD tree hashing or this LSH, right? So hashing based method like LSH, local sensitivity hashing. Okay. Or neural network based technique also. So guys, this is all the advanced thing. Basically, whenever we are going to discuss about the vector database, definitely I will let you know how this indexing and all works, right? But I think many times we have created the indexing and all. If you will look into the vector search, which we have created with respect to the MongoDB in the previous session, there also we have used the KNN. Okay, this KNN or this KD tree, right? If you will look into the if you look into the behind scene, okay, the behind functionality of that vector search, you will find out they are using the KNN and this KD tree, KD wall tree, for what? For the indexing mechanism. Okay, now how to do that, I will let you know in the upcoming session. So advantage of the vector database is it provides the efficiency with respect to this similarity search and all. It provides the scalability in terms of storage. It provides the precision accuracy with respect to the like similarity search. Okay, speed, simplicity. So these are pretty common advantage of the vector search, right? So people are using this vector databases. It's a quite long time they are using in the industry of this, in the like NLP industry, in the generative AI industry. But nowadays it's a quite popular because of this generative AI application. Because each and every type of data we can convert into the embedding and we can store it inside the vector database. So here one side you have seen the NoSQL database and other side actually you have seen the vector database. Now guys, nowadays we can use this NoSQL database. So here inside this NoSQL databases, they have given the mechanism, right? They have given the mechanism of this vector search. So directly we can store the data. Okay, directly we can store the data and we can make the similarity search with respect to the embedding. So that same thing actually I have explained you in my previous session. Okay, if you look into my YouTube channel, so there actually you will find out one solution, RAG solution with respect to the MongoDB. Like one day back only I have uploaded it. Definitely you can check it out. And here I have used the Gima model from the Hugging Face, from the it's a Google model, and I've created one RAG application. So here I'm trying to giving you the flavor of each and everything. So definitely you should check out if you haven't checked out so far. Now, one more thing I would like to say here. So I hope this thing is clear. NoSQL and vector. Now coming to the next part. So this is all the example. Okay, this is all the example of the vector database. Now, guys, whenever we are talking about the vector database, so we use this vector database generally for the information retrieval, QA system, or a recommendation system. There generally we are going to be create this RAG architecture, retrieval augment generation. And I think you know, like this RAG. What is the RAG? If you are following my video, because I try to explain you in each and every ways. Okay, now here's some sort of an example of the vector database. So Chroma, Pinecone, Vector, Milvus, right? Or Fize, Quadrant, Spavald, Vector Flow, OpenSearch, PG Vector. There are lots of vector database, but these are quite famous one and people are using in a real time also. Now here guys, what you can do, you can divide into two parts, means you can divide into open source and the closed source. So this is the assignment for all of you. I just written it for all of you. Okay, now coming over here, so if you want to read that the differences between this NoSQL and this vector database, definitely you can check. I have kept over here. So if we're going to talk about the data modeling and structure, I already explained you that we have 4 model inside the NoSQL, and here we have a vector inside the vector database. Primary use cases, so it is suitable for any type of application, any type of web application. Okay, because we can store any type of data inside this NoSQL database. Now, other hand, if we are talking about the vector database, so it is useful for the NLP or generative AI related application. Means I would say AI related application where we are going to be convert our data into the embedding. Getting my point? I hope yes, right? Now apart from that, query functionality, so yes, we can perform this CRUD operation, which is a very well-known operations with respect to the database. Now here we can just only do the similarity search, like cosine similarity, Euclidean distance. Okay, these are the different similarity search, like dot product and all. Performance of the optimization, yes, these are very powerful, and in the real time many companies are using it. So here it is being used across many servers, and it is providing the excellent service. Now here if we are talking about the vector database, so yes, wherever we have an embedding, so we are using this vector databases over there for storing it, for keeping it, for retrieval, and for the generation. I hope this thing is clear to all of you. Now guys, from here the story is going to be start. Okay, so here the story is NoSQL or SQL databases, which nowadays we can use as a vector search, because they are providing the info. They are also actually they are providing the mechanism of the similarity search. Okay, so here guys, see, if you will search about the MongoDB, so MongoDB is also providing the vector search. I think in my previous video I have explained. If you will check with the data stack, okay, so this is the Redis. Redis is also providing the vector database, and here this Redis actually it's a NoSQL database. Now here if you will find out this data stack actually Cassandra. So MongoDB Atlas, it's a cloud form of the MongoDB, similar to the data stack is a cloud form of the Cassandra, right? It is also providing the vector search for the real-time AI, and soon I will be uploading the solution related to that. Okay, so guys, here the thing is these are the database: MongoDB, Cassandra, Redis, Elasticsearch, Neo4j, Postgre. We can use it for the as a vector database also. Now what is the combined solution then, right? What is the combined solution if this vector database, if we can use this NoSQL database as a vector database also? See, sometimes guys, see, NoSQL database is what? MongoDB, Cassandra and all. Vector database, Pinecone, Quadrant, LensDB and all. So here guys, see, in the real time the data will be very huge. So let's say in my data, I'm just taking the previous problem statement where I was having around 20 column. So the 20 column actually it was representing to the different thing, and one column actually with respect to the one column only I was creating the embedding. Okay, embedding. Now here guys, this embedding I can solve it by using the MongoDB search also, but here what we have seen in the real time, this vector DB is having some advantage on top of what? On top of this NoSQL vector search, right? So what are advantage it is having? So here you can see I have mentioned couple of advantage. So optimize handling for high dimensional vector data. Maybe this NoSQL database, it is not able to reach to that particular point where we can handle the high dimensional data, but yes, this vector database is specifically, which specifically has been designed for the embedding only, they can handle this high dimensional data. Real site searching is also possible, and improve similarity search and the advanced indexing also. So here advanced embedding and the indexing, sorry, it's a indexing, guys. Okay, so this all the thing basically we will find out in some databases, in some vector databases, and where people are doing what they are doing, you know. So rest of the data they are storing inside the NoSQL database, and other database they are using inside the other data, basically embedding data, they are using inside the vector database. Getting my point? So here let's say we have 20 column, and inside this 20 column, 19 column we are going to be, so 20 column, all the 20 column we are going to be stored inside this NoSQL, and one column, okay, with respect to that we have to generate the embedding, so that a particular column, okay, embedding column, we are going to be stored inside the vector database. So that is my use case which I'm going to be solved over here, and which is very much important as well. So this type of thing you can mention inside your resume also, guys, because if you are going to be create a rack, they will ask you how did you solve it, what are the possibility over here. Okay, now what I'm doing, so here I'm showing you one website, and this website basically it will be clarify your most of the doubt, right? So here what we are going to do, see, here we are going to do a vector comparison. Definitely you can check out with this particular link, and you can look into the vector comparison. So here comparison wise, if you will look over here, so they have divided into different section. First section is about, means it's a generic detail, right? The second section, which is called search, right? Search. So hybrid search, facet, okay, geo search, multi-vector, sparse, right? Or here multi-model search, full text. Then they have mentioned the model. Then here you'll find out the API. Okay, apart from that you'll find out this operations, right? Means pricing and all, everything. And then you will find out the states. Okay, so guys, based on this actually they are going to make a comparison. So here if you will look into the database, let's say here is what, here's my MongoDB database, you'll find out. So just look over here, MongoDB database, and here is what, here's my Pinecone. So just try to be look over here, and what we can do, we can make some sort of a comparison. Just wait, let me open my Epic Pen so that I can highlight some sort of a points over here. I hope guys this is looking interesting. If you're finding out it is an interesting one, and definitely if it is adding you some learning, okay, in your generative AI journey, then please subscribe it, please subscribe the channel, and please hit the like button. Soon I'll be uploading many more solution like this. In the future also you'll find out many more things from my side. So see guys, see here, if you will look over here inside the MongoDB and this Pinecone, right? Now here MongoDB actually search wise, we can do this particular search. Now first of all let me do like this because it is hidden. So filters, right? So it is providing the filters. Yes, Pinecone also it is providing the filters. Now here hybrid search, so yes, MongoDB is providing the hybrid search. Now here this is also providing the hybrid search. Facets, right? So it is providing the facet. Now it is not providing you that this one. Now here if you will look at the facet, so what is the meaning of this? So just like hover your mouse, you will get the definition. Build an aggregation of facet and facet cardinality calculation. Okay, so here what is the meaning of it? Means you can aggregate all the thing like we were doing inside the MongoDB. Okay, we were creating one pipeline and we were aggregating that. Here it is not like that. Okay, so that is not a big thing. Actually it's a database specific thing. Now geo search, so it is providing the geo search and it is not providing you. Now here multi-vector, so here it is providing the multi-vector, it is not providing you this one. Okay, this one is not providing. Now here sparse vector, so it is not providing you this sparse vector. Now here Pinecone actually it is providing the sparse vector. Now BM25 actually it is related to the multimodality, so images, text, table and all. So here it is providing you this, it is not providing you that. Okay, it is providing you that, and here it is not providing you that. So here you will find out, see guys, this MongoDB and this Pinecone. MongoDB vector search is having some advantage on top of the Pinecone. But guys, see, every database is not a same one. If you will look into the other points, so definitely somewhere Pinecone is dominating. But sometime actually MongoDB is also dominating. It is having like sufficient functionality. So here my main motto to teach you how you can build the combined solution. So instead, let's say if MongoDB is providing you all the thing which sometime Pinecone is not having, in that case, just go and check with the other database. So let me tell you some other powerful database, Quadrant, right? Just look into this database, and here guys you'll find out it is providing the most of the thing which is not with this like MongoDB or this any other NoSQL database, any other vector search is not having those things. Quadrant is there. PG vector. So PG vector I haven't used. Quadrant I have used. LensDB guys, right? Pinecone is also. So just try to be explore based on the other factor over here, and you can take your decision, right? So here my main motto is what? So here my main motto to teach you this combined solution. One side NoSQL for the data, metadata, and one side vector DB specifically for the embedding. Okay, don't use the Pinecone if you are finding out, let's say if you are going to be compared over here, and if you are finding out that okay, MongoDB search is better compared to the Pinecone, don't use the Pinecone, but you can look into the other database. Okay, and based on that you can select, based on this particular parameter and all, you can select that particular database for your solution. Just an experimental thing. Got it? Okay, now what we are going to do, now we are going to see the practical implementation. I hope this is clear to all of you. So what I'm doing guys, so here let me show you that particular part, MongoDB and Pinecone with real time rack pipeline. I hope guys till here everything is fine. Now look into the practical. So here, first of all, we'll have to be install few libraries. So let me import those libraries. Pip install Pinecone client. Okay, so Pinecone is required if you want to use this Pinecone. So the second one which is required, that is MongoDB. So pip install Pymongo. So Pymongo is there. Now the third one which is required over here, that is going to be a transformer. Okay. So let me import the transformer over here. Pip install transformer. Or what I will do, transformer actually I'll be installing later on whenever I will be showing the rack part. So as of now I'm just showing you the ingestion part. So Pyco transformer is not required. Okay, now okay, let me do it because yes, I will have to do the embedding. So yes, for the embedding I forgot that because we are going to be ingest the data in the form of vector only, right? Transformer. So now let me write it down, this transformer. After this one, what I will do, so I will be connecting with my MongoDB. For connecting with my MongoDB, here what you need to do, first of all, you need to open your MongoDB. So here is what guys, here is my MongoDB. I already opened. Now let me show you how to open it. Okay, so here what I'm going to do, I'm going to be sign out from. So let me log out and I'm showing you from scratch. Even though I showed you in my previous video, but again, I do that part. Okay, so here itself. Now, once you will open the MongoDB page, if you will click on the login, so you will get this particular part. So simply you can log in with your Google, with your Gmail ID or with any other ID. So here I'm going to be logging with my email ID. So here I log in with this particular ID. Now after login, what I will do, show you that part. Yeah. So after login here, what you need to do, you need to focus on three part here. First is database. So here actually you can what you can do, you can go through with your browse collection and all, everything you can see, right? Even you can connect also. I will show you this connection part. The second is what, quick start. If you haven't defined your username and password, try to create your username and password which is required for the. And third one is what, network access. So here actually you can add your IP. Okay, so this is going to be IP. Just click over here, add IP, and then definitely you will be able to add it. Now once you will click on this database, so here is the option to connect. Now once you will click on this connect, it will give you the option for the driver. Just click on top of this driver. Here you will find out the different driver. So whatever language you are using, according to that you can select. I'm using this Python driver. I'm going to select this one. So I'll be required this particular installation, which I already did by Mongo. If you want to do it from here, you can do it. Now you just need to click over here, this full code. Okay, view full code. So you will get this entire code. Just copy from here and then paste it inside your code, inside your notebook. So this is your notebook guys, just paste it over here, and then here you need to write your password, whatever password you have defined with respect to your username. So you can mention password. This is my password I'm mentioning over here. Now if I'm running it and I'm getting this particular message, then everything is perfect over. Let me run it and let me check. So let's see guys what I will be getting. So yes, I am getting this ping your deployment. You successfully connected to the Mongo DB. Now similar to that, I required this a Pinecone one. So for the Pinecone guys, what you need to do? So first of all, you need to log into your Pinecone. So let me show you from scratch. So let's say here is what here I'm searching about Pine. Now once I will search about Pinecone, so here you will get the very first link. Just click over here, and then it will give you the option for the login. Just log in and you can select with any ID. Let me log out from here and let me log in with a different mail ID so that I can show you the process from very scratch. Now continue with the ID, continue with the login. Then here is what here I'm going to log in with the same ID. Okay, this one. Now I'm going to continue here. And after that, I'll be required two things over here. First is index and the second is the API key. Okay. So let me create the index and let me create the API key as well. So here is my API key guys. So see, by default, it will provide you one API key. So definitely you can check it. Now let me copy it over here and let me keep it inside my Pinecone. Great. Now the other thing what I will be required. So here I will be required this index. So let me create the index here. Index you can write any name. So let's say I'm writing. Then dimension, let's say I'm going to be define dimension 384, but you can define anything. Now similarity, cosine similarity, everything is fine. Serverless, yes. Okay. Cloud provider AWS, correct. Region is this one. And create index. Click on create index. Okay. So here guys, you can see I'm able to create this particular index, right? Which index guys? Tell me this index over. Now, first of all, let me log out from here because it's not required at all. Here it is mine. Now if you look into the API key, so I have just one API key, that is a default. I logged out from here as well, no issue. So I'm going to be logging with us. Just a second. So what I got my okay, great. Now here's my API key. Now what I will do, I will just simply click on this connect and Pinecone client I already did it, I already installed. Now just copy this particular code and here keep it inside your collab. Then API key wise, remove this one. I already did it, so it's the same actually. Let me define this particular variable. Okay, and what is my index name? My index name is a Mongo. You can define this. Okay, so now what I can do, run it. So here you can see I created my index, but you can check. This is my index, right? Now what I have to do, so here's my client. So by using the client, I'm going to create the database, right? Set the Mongo. Now here my database name is my okay, my I can write my test. Now this is my database, and here I can collect it over. Then I'm going to be now here what I can do, I can create a collection. So inside the collection only my data will be available. So here my collection name is going to be my collection. Okay. Now what I can do, I can keep it inside the collection. This is what my collection. Got it? Now what I will do here, DB and collection is there. Now I will be storing the data, and corresponding to the data, I'll be storing the dimension inside the Pinecone. Okay. So here is the key. Here is the code, guys. Let me give it to you. I already kept with me. So this is the code, guys. This is the entire code. Okay. Now over here, guys, see. This is the entire code which is required over here for updating everything simultaneously. Now one more thing is required because I want to store the embedding. I'll be required the embedding model. So let me take the embedding model from the Hugging Face. So this is going to be my embedding. And here, guys, this is my embedding model. Okay. Now sentence transformer is what? It's my model. Sorry, this one. All mini LM L6 V2. It's an open source embedding model. Now I hope everything is perfect. Everything is fine. Now what I can do, one thing. Let me import something over here, guys. So here I'm going to be import. I required this transformer. Utils is not required. Mongo client, Mongo client, I already installed over here. Now the next thing is what? So here it is saying sentence transformer is not there. Install this transformer. So simply I can write over here pip install sentence transformer is getting. Now after that, see this is not Mongo. I already have it. So Pinecone also I have import. Don't need to worry about. Already I required this. So let it install. So now it has installed. So after installation, guys, let me import it, and it is imported perfectly. Then I have to load this model. So I'm able to load my embedding model until I can like explain you until let me explain you this particular part. So here I am watching to the collection. So inside the collection, actually, I'm whatever collection I'm going to be store the data. In my case, the collection name is what? In my case, the collection name is this one, my test collection. So whenever so here I'm watching the collection, whether it's going to be change or something inside the collection. See, it is running inside this while loop. So whenever any changes will be there, it will be detected, right? So change operation type, what type of operation you are going to perform over there inside the collection. So let's say the operation type is insert, means we are going to be insert the data. So here what I will do. So this data is going to be insert. So that data actually we can data is called document, right? So it will be there automatically inside this full document variable. So what I'm doing, I'm going to be collect this document. Then from there actually I'm going to take a variable. So here my variable name full plot. I will let you know why I have written this full plot. Okay. So here I will be creating a vector with respect to this particular data, because whatever data I will show you, my previous session I have shown you the movie data. So inside the movie data, there was one column full plot. Okay, the complete description of the movie. So that particular column basically we were embedding. Okay, we were creating the embedding with respect to that column. So the same column actually I am going to be embed over here. I will show you with respect to the single document. Don't worry. Now we have a vector, so I will be creating a list of the vector. Is this array I am getting. So I'm just converting to the list, and then here what I have a floating point list. Okay, so this is what this is my vector. Now here guys, what I'm doing, so this is my ID with respect to the document, because whenever I'm going to be store any data inside the MongoDB, with respect to that I will be getting one unique ID. I have shown you in my previous classes. If you don't know, let me show you that. So this is the one. Let me show you the collection. As of now I don't have any sort of a collection over here, but I have, but until unless we are not going to be store the data, that will not be showcased over here, right? So let me show you this one. So here you will find out this is what this is the data, and here is what here is the ID, right? So automatically this ID will be appended over here. Now what I have to do, so let me show you the next part. So after that we are going to be keep this ID. Okay, this is my ID, this is my vector, and both thing actually I'm going to be append over there. So if I'm going to be insert, in that case, so it is going to be update. If it is going to be insert the embedding. Okay, whenever we are going to be insert any new row, in that case it's going to be insert the embedding with respect to that row. Okay, here if I'm going to be update that row, in that case also my embedding is going to be update. If we are going to be delete, then definitely embedding is also going to be delete. Okay, this is what this is my code. Now let me execute it. So here this will be executing, guys. So this required a like different instances. Now what I can do, I can show you the MongoDB operation inside the new notebook, right? So here this is like continuously watching, and this will have to be run over the different server. So either you can do the multi-threading or multi-processing over here, or else you can run it over the different terminal or different instance. Now here what I can do, let me show you the MongoDB operation. So whenever we are going to be store any data inside the MongoDB, now let me do one thing. MongoDB, this is going to be running. I think I can show you where. Let me select the runtime different over here. So maybe I will be able to connect it. Connect to TPU. So here I think it is saying too many sessions. Let me check whether any other session is connected or those. Post. Okay, I disconnected other session is. Let me check, or I will have to use a different ID in that case. Let me use. no worries, I can use the different id over here, let it run this particular thing. So because there are my too many sessions was running, I don't know which one like it is detecting, but it is not able to connect. So here I'm going to be connect with my different mail id, and now I'm going to perform the MongoDB operation. So first of all guys, let me show you the MongoDB operation, what all operation I can perform. So here I will be required this PyMongo, okay, because I want to store the data inside the Mongo. Now I will be required this the next thing guys, let me show you which one, this particular code. So here I required this code. I'm just taking a code from my previous file itself, so not required this this particular thing, this Pinecone and this one. And here I just required this Mongo client. So let me run whether my Mongo client is working fine or not. So here my Mongo client is working fine with the same username and password. Now guys, what I will do, so here is what, here is my collection and my here's my collection and database. So my test database and here my test collection, this is the name. I'm going to be connected. Now I'm going to be store the data over here. So if I want to store the data, so here what I can do, I can simply take a data. So let me show you the data. So this is the data guys, which I took from my previous data itself, previous problem statement itself. So movie name, genre, rating, and here is a complete plot of the movie, right? So now you will see whenever I'm going to be store any sort of a data inside my MongoDB corresponding to this full plot, right? So here full plot is what, sentence, but corresponding to this full plot, automatically the embedding will be uploaded inside the Pinecone, right? Let me show you. There is my data. Now let me insert this particular data. So here is what, client underscore one. Now let me take this data and let me copy and paste over here. So this is data, and here I'm going to be inserted. Now let me insert it and let's see whether it work or not. So see guys, this row has inserted. Now if you will check with the MongoDB, this one guys. So here if you will check with the MongoDB, see my test data, let me refresh it over here. So here you will get the collection and the database both. So my test DB, this is my database, this is my collection, and inside this collection you find out this. You'll find out what guys, tell me, you'll find out this data, right, inside this collection. Now this is my object ID and this is what, this is my full plot. Okay, let me show you the Pinecone. So here is what, here's my Pinecone, and just see the vector and see, let me refresh it. Let me show you the ID and let me show you the embedding over here. So see, automatically it's uploading. So metadata we are uploading there inside the MongoDB, and the vector we are uploading over here. This is the ID 633A. You can check 633A, and corresponding to that we have any sort of a document. Let's see. Let's try to import. Let's try to write any different document, right? So here what I'm doing. So where is my see? There my server is still running. Okay, it is continuously watching to this collection. Now here, let's say if I'm going to be in keep any other data point. So let's say here I'm going to be keep, let me remove it, and here I kept one more movie name. Let me show you that. So this is the different movie name. The movie name is, or the movie Dangal, it's a Hindi movie, right? So here I'm going to be like store it. Now see, I got my what I got guys, tell me. So here let me refresh it. So I got my data over here, my metadata, and corresponding to that, corresponding to this metadata, I'll be finding out the embedding inside the MongoDB. See, vector count 2. Now let me show you that. Once you will refresh it, so here you'll be find out the second. Here you will find out the second embedding. So everything is working in a synchronized mode. This is what, this is my second. Okay, 633A, 26A, 186. You can check 186. Getting my point. Now let's say if we are going to delete it, this one. Okay, this. Well, just see guys, if we are going to delete it. Okay, we have deleted, we just have only one. Now see over here. So this is also going to be deleted. Let me show you. See, vector count is 1. Now let me refresh it, and here you will find out only, here you will find out guys, tell me, only 1. Okay, so here is what, here is only 1. Now I hope this thing is clear to all of you. So we have synchronized both MongoDB and Pinecone. Likewise, you can synchronize any other database. Okay, you just need to write a configuration over there. That's it. Now in the next class I will show you the retrieval augment generation. This is just an ingestion. Try to do the retrieval and the augmentation. Thank you guys, thank you for watching this video. We'll meet in the next video. Until, thank you, bye bye.